Okay, Mr. Haddock, I think you're set. I'm going back to the Ideal Lay Lab
Okay.
to hang out with my friends.
How are you doing, Kylie? Good. We'll wait a couple more minutes and see if anybody else joins on. Matt's not going to be here. He's doing an interview for Bruce Mitchell or something like that. Anybody else you know that's not going to be here? Everybody hear me?
Yep.
Does anybody know of anybody that's not going to be here?
No, I don't.
Addison was working today, but she said she was going to probably be on.
Okay. Today, we're not going to be very long. We're probably going to be done out of here by 11:15, 11:20. So we're not going to be very long at all. We had an assignment on page 476. Did anybody have any questions on any of those problems? Now, Sydney, I got your assignment, and I got Garrett's, and I think I have Matt's. And believe it or not, I think I have Parker's. Let's look at problem number 10. And we're going to find the natural log of the square root of x. We're going to integrate the natural log of the square root of x in terms of x. There is no formula on page 403. There's no substitution that you can do. So we're going to try and do this in terms of integration by parts. And the integration by parts formula, I just wrote it up on top of the board. So we're going to break this up into two parts, and we're going to break it up into this part and this part. Now, Sydney, I noticed on your problem, you broke it up. You wrote x as x to the 1/2 power, and then you put the 1/2 with the dx.
Yeah.
That's a 1/2 power. You can't just take the power and move it anywhere you want. Okay, we're going to have to let u be equal to the natural log of the square root of x. That's what u is equal to, always equal to the natural log. And then we'll let dv be equal to dx and see what happens here. Well, what's the derivative of the natural log of x, the square root of x? Well, supposedly, it's supposed to be 1 over the function times the derivative of the function. So this is going to be 1 over the square root of x times the derivative of the square root of x, which is 1 over 2 square root of x. Okay. This is x to the 1/2 power. So we take the exponent times the number in front to the exponent minus 1, and it's going to look like that. So the derivative of u is du. The derivative of the natural log of the square root of x is 1 over the function times the derivative of the function. And so if I write this, if I take this square root of x times this square root of x, I'm just going to get x. Okay. So this is what u is equal to. This is what du is equal to. And the antiderivative of dv is v, and the antiderivative of dx is x. So when we write this answer, it's going to be u times v. So it's going to be this number times this number, minus the antiderivative of this number times this number. So it's going to be x times 1 over 2x. Now you notice here that the x's cancel out. So what we want to do is just take the antiderivative of 1/2. And the antiderivative of 1/2 is 1/2 x. Okay. So that's the way that it's done. You let u be equal to the natural log and dv be equal to dx. The derivative of the natural log is 1 over the function times the derivative of the function, which comes down to this. Antiderivative of dv is v, the antiderivative of dx is x. The answer is u times v minus the antiderivative of v times du. So when you multiply these together, you just get 1/2. And the antiderivative of 1/2 in terms of x is 1/2 x. So that was number 10. Okay. Any questions on any of those others? We had 1, 2, 3, 4, 10, 26.
Can we go over number 1?
X cosine, or excuse me, it's x e to the 2x, right?
Yeah.
And you can do this by the shortcut that I showed you last week because you have x to the first power. Or you can just go ahead and they say let u be equal to x. And then the rest of it be dv. So when I take the derivative of u, I get du, and the derivative of x is dx. The antiderivative is just v. What's the antiderivative of e to the 2x? Well, you should do that by substitution because we don't have any rule for the antiderivative of e to the 2x. So you'd let u be equal to 2x, then when you do the derivative, just get 2, and it becomes a half. And so when you have the sine functions, cosine functions, base e, this is just itself divided by the derivative of the exponent. When you take the derivative, you multiply by the derivative of the exponent. When you take the antiderivative, you just divide. So this answer is u times v. So you're going to have this number times this number minus the antiderivative of v times du. Well, here's v and here's du. So if you take the antiderivative of e to the 2x over 2, the antiderivative of e to the 2x is itself divided by 2. So you got divided by 2 and then divided by 2 again is going to be divided by 4. So your answer is x e to the 2x over 2 minus e to the 2x over 4. You just have to remember how to take the derivative, antiderivative of e to the 2x by the shortcut. If you put u equals x and dv is equal to e to the 2x, the derivative of x is 1 and the derivative of 1 is 0. The antiderivative of e to the 2x is e to the 2x over 2. The antiderivative of e to the 2x over 4 is e to the 2x. Antiderivative of e to the 2x over 2 is e to the 2x over 4. And so you have x e to the 2x over 2, and then you have minus 1 e to the 2x over 4 plus c. So either way you do it is going to be the same. Okay? Everybody okay with that?
Yep.
Okay, what I need you to do, since this is our last meeting, and like I said, it's not going to be very long. This is our last meeting. I need assignments. So I need you to turn in all missing assignments, and I'm going to put you at a deadline. I think I said Friday, but I think I'm going to give you a little more time. I'm going to do a deadline of Sunday. So every assignment that you have that you can get in by Sunday. Okay. And then I want to kind of give you some words of advice. This class, you're going to have a high school grade for the second semester, and then you're going to get a college grade for the whole year. And all of you, I assume, are going to go college at one time or another. It doesn't matter whether you go next year or 2 years down the line or 3 years down the line, but you're going to have that college grade on your transcript. And so you're going to have to make a decision. And this is what I tell the kids every year, and it doesn't make any difference. This year's a little different. So this is doubly important because of the virus. We've lost out on a lot of the last 9 weeks. We didn't do a lot of the things that we could have done and we could have finished and we could have spent much more time. I think we've met 10 times by Zoom as compared to 40 times if we would have had the whole semester. So that's only about 1/4 of the time that we've met. So it's not a true indication of what we're capable of doing. So each one of you probably are going to go to college at one time or another. The teacher, the professor, your mentor, whatever you want to call them, they're going to look at that and they say, okay, I see you got a B in calculus, calculus 1. We're going to put you in calculus 2, or we're going to ask you to start here and do that. And I would suggest to you that you tell them no, that you don't want to do calculus 2. You want to do calculus 1 again because of the holes that we have. And in fact, I would encourage you, they used to have classes called college algebra and trig. This class, your senior class has some definite holes in your algebra and in your geometry and in your algebra 2 and in your trig. There's a lot of spaces in there that need to be caught up. So my suggestion to you, and it's my suggestion to everybody that I've done for the last 50 years, is that try to take a college algebra and trig class first semester. Couple reasons. One, it would fill in a lot of the holes for you. It would be homework that would last, probably you'd have 2 or 3 hours of homework a week, which is not very much. If you were to take calculus over again, it's going to be 7 to 10 hours a week. If you were to take calculus 2, you're looking at 14 to 15 hours a week. If you're like me, and I've been your age, you've never been my age, you're going to go to college for the first time. There's going to be choices that you have to make. If you're like me, unfortunately, sometimes you make bad choices. Should I study for the test, or should I go to the student union building and play pool? I went to the student union building and played pool. So I would suggest that first semester, since we're not always going to make good choices, is you take a load that is less. 1 to 2 hours a week is way better than 7 or 8 hours a week. It would fill in your holes. It would give you time to adapt to the college life, what you have to do and what you can't do, and get along. Okay. The best advice I ever got was from a former student that said that he'd go to class, and if he didn't have a class the next hour, he went to the library. He never went back to the dorm because at the dorm he couldn't get things done. So he'd leave class, go to the library for an hour, go over all his notes, do over all his assignment, then go to his next class. If he didn't have a class over that, he went back to the library, which is really, really a good idea. It's one that I never crossed my mind to ever do something like that. So I would suggest that you try to take a class before, maybe they call it pre-calculus now, they called it college algebra and trig. When I was in school, it was a review of all of your high school math. It made it very, very easy. Then the second semester you went into calculus 1. And then the next year you did calculus 2 and calculus 3. So that's my suggestion to you. you can take it for what it is. So I just think that would be good for your class as a whole. And especially if you're going to go on in math, we didn't do a whole lot of theory in calculus. There's a lot of theory that they're going to cover on the college level that would make calculus make a lot more sense. So we didn't do a lot of that. We tried to find uses for it more than anything else. So be patient when you go to college, and don't let them try to bluff you into going to Calculus 2 when you're not ready. And they'll ask you to do that, and you tell them as soon as they're paying for your college, then you'll do what they tell you. As long as you're paying for your college, you do what you need to do. So that's my suggestion for what it's worth, right? The class is weird. This class is weird because of what happened in this last 9 weeks. It's been kind of a pain in the butt, basically. It's been really, really difficult for me because I can't do any of the things that we've done without Mrs. Jensen loading everything up and telling me what to do step by step. Okay? I need for you to turn in your books, completely cleaned out, no papers left in it, and your calculators. And I think the best way for me to do that is to meet with you on next Tuesday at 11 o'clock. And next Tuesday at 11 o'clock, I will be outside the Bruce Mitchell lab. And I just need for you to come and meet me at the lab, outside the lab. And I will take your book and wipe it down, and take your calculator and wipe it down. And hopefully that time I will be able to tell you your Parma High School grade as well as your college grade. And I will send an email to you to that effect, probably Saturday or Sunday, just to remind you, maybe even Monday to remind you. But we'll turn in the books and the calculators on next Tuesday, just our normal time at 11 o'clock out in front of the Bruce Mitchell building. Okay?
Okay.
All right.
Sounds good.
Anybody have any questions?
I don't.
Okay. Thanks a lot. I enjoyed the year. I wish you were a lot noisier than you are. You haven't said but maybe 6 words all year long. You need to be a lot noisier because there's an old saying, the squeaky wheel gets the oil, and that's very, very true. So stand up for yourself and be a little bit more, well, I don't want to say outgoing to you, Lane, because that would put you over the edge, but.
What are you talking about?
Okay. All right. Thank you, guys. I will see you then. I'll see you on Tuesday, next Tuesday, when we turn everything in.
Thank you.
Thank
Thank you.
you.
Thank you.
Thank you.
Here. What, is your mom coming to pick you up?
I've read it.
Huh?
I've read, yes. Alan actually said he ran into you and harassed you yesterday.
Yeah, yeah. That's kind of scary that he was one of my first